I welcome you all for this lecture series. A very good morning to all. Uh, this course, Mechanics of Solids, is very important for mechanical engineers as they are the roots of building any component or any device or any automobile component. Any engineering application starts with the material. So studying the strength of materials is very important for mechanical engineers. This mechanics of solids will try to teach the basics of all this material strength. So in the unit 1, we are going to go through stress, strain and deformation of solids. So actually we have solid mechanics, fluid mechanics and engineering mechanics. What is the difference between engineering mechanics and solid mechanics? So engineering mechanics is the science which deals with mechanics of rigid bodies, that is the force at the load and the deformation happening in a rigid body. And mechanics of solids deals with both rigid bodies as well as deformable bodies. So that is our today's topic, rigid bodies and deformable bodies. That is the foundations of solid mechanics. So what is a rigid body? First of all, we'll look it in the picture in the right side where there is a nail which is hammered through a hammer. So the real world example is hammer under normal use where its deformation is minimal. There is no deformation, that is rigid body, which is defined as the body with negligible deformation under load, assumed to be perfectly stiff for simplified analysis in statics and dynamics, enables focus on forces, moments, and motion without considering shape changes. So coming to deformable bodies, a body which can change their shape or size when it's subjected to external force, that is internal stresses and strains developed to resist this deformation. Critical in strength of materials and structural design, like for example, when you are manufacturing any automobile component, for example, we'll take a car. So that is subjected to a crash test. That is, when the car hits a barricade or a tree or a vehicle which is in front of that, how it gets deformed. That is called a crash test. The stability of the front portion of the car, that is, we call it as a bumper or something like that. This sheet metal should have the strength, or it should be rigid. It should not get deformed, and it should not cause any injury to the passengers. That is called deformable solid. This car crumpling into crash test demonstrating significant changes in the form. So this is a deformable solid. And mechanics of rigid bodies, where the core concepts are equilibrium forces, focus, that is forces and moments, balance of or static or constant velocity states, and motion description, simplified problems, that is fewer degrees of freedom leading to easier calculations, and foundational for basics for classic statics and dynamic courses. So mechanics of deformable solids, we have four core concepts, that is stress and strain, study of material response under load, how a material gets respond whenever there is an external load, and constitutive relations, links between stress and strain, that is Hooke's law, which states that any solid which is subjected to an external load, the stress is directly proportional to strain within the elastic limit, that is Hooke's law. And the third one is analysis scope, includes deformation, deflection and failure modes. And the fourth one is design essential, that is crucial for safe, efficient structures and materials. Visualizing deformation, which is basically through stress and strain, that internal force per unit area resisting external load, we call it as stress, and a measure of deformation, that is actual dimensions to the original dimensions after the loading is done, we call it as strain, which has no unit. An elastic spring stretching and returning to its original length, demonstrating Hooke's law behavior, which is shown here in this diagram. And it is why both matter in engineering, that rigid body mechanics and solid body mechanics, deformable body mechanics are crucial in understanding real world problems. So combined mastery enables innovation in design, analysis, and material science. I hope you all understood what is rigid body and what is deformable body and what are the applications of that, and that we see in a small mind map here. We have seen what is rigid body and what is deformable body, what is stress and strain, and what is the engineering significance of this rigid body mechanics, deformable body mechanics, and combined mastery. So thank you all for the patient listening. We'll meet you in the next lecture series. Thank you.